All right, let's look at number 1 then. That's 3n squared plus 2n plus 1 over 2n squared plus n. Notice the power of the top, the highest power on the top is the same as the highest power on the bottom. So you're just going to probably look at for, really the easiest thing to do is always think about the test for divergence and just look at the limit of the terms, as n goes to infinity, of 3n squared plus 2n plus 1 over 2n squared plus n. Well, I think most of you should know this is pretty much just going to be, 3 over 2. That's not equal to 0. And so we have, by the test for divergence, this number 1 diverges. Because eventually you're just going to be adding things that are like 3 halves plus 3 halves plus 3 halves plus 3 halves. It's going to get really big. All right, let's think about number 2 there. So this time we could do the test for divergence real quick just to see. N goes to infinity of n squared over n cubed plus 1, but that equals 0, so test for divergence doesn't give us anything. Let's think about what does that seem similar to? What do you think that would be? We're probably going to think about the limit comparison test now. The difference in the highest order of the top term and the highest order of the bottom portion, the denominator, there's a 1 over n difference, right? So let's think about, maybe we compare that, do the limit comparison test. With n squared, n cubed plus 1, and 1 over n. So let's see. So we're going to compare, we're going to use the limit comparison test to compare it with this. Starting at 1? Oh, it's actually starting at 2. Oh, whatever. So we know this one diverges. So if we get a number between, if we get a real number, a non-zero real number, we know that this our number 2 actually diverges as well. So let's see. This is the limit as n goes to infinity of n on top, so it's just going to be n to the third over plus 1. And what is that? That's 1. So there you go. We know by the limit comparison test, since this one diverges, number 2 also diverges. Oh, diverges. Wow, this is so cool. So finally, we're just going to do number 3 down here. Let's see. Number 3 is 3n. I'll just write it again. Why not? 3n over 2 to the n factorial. So as soon as I see something to the power of n, I'm immediately thinking root test for the most part. Let's put in the mix. So let's see. What's the root test say? We take the limit as n goes to infinity of the root of the terms, the nth root of the terms. Factorial. Let's see. It's going to be limit as n goes to infinity of 3 over nth root of 2 to the n factorial. So let's see. Is this going to be? Now you gotta think, because if this bottom term is going to some number, then it tells us we need to know if this bottom term is going to infinity or not. So sometimes you fail, and that's okay. We all fail. So let's try the ratio test this time. N goes to infinity of, let's see, 3 to the n plus 1 over n plus 1 factorial, and then, oh wait, is the factorial? No, the n factorial is by itself. 2 is not in there. Okay. 3 to the n. And so I'm running out of room. Equals limit of 3 over 2's cancel. With the exponents cancel there. And then our n factorial is going to cancel with all but an n plus 1. And that goes, that's just going to be equal to infinity. And so, wait, 0, sorry. Oh man, 0. All right. Yes, because n's going to infinity. I was thinking about n going to -1 for some reason. All right. And so, wait, does the ratio test give us anything if it equals 0? People should be nodding their heads yes. Okay, cool. And so we know that this converges. Let's go. Number 3. Oh, God, converges. Such a long word. Okay. Oh, it's right at the bottom, too. No, I can't lift it up. Okay, what do I do?